Check. Okay. Yeah, so generally I kind of talk this topic in a developer folks or kind of an architecture. I have another version of this slide where how to make your application resilient. That's another version of this slide. I want to make it, but I kind of tweak it, and this is unconf, focused on QA. So I wanted to introduce something new, which might be helpful for you guys as well. So before I jump into this, I believe most of you are QA here. Anybody dev or mix? I don't like this differentiation in role, but this is how the industry has differentiated, unfortunately for us.
It is what it is.
It is what it is. Yeah, so I think this is great. Okay, I'll just quickly introduce myself. My name is Ashish. I work for ThoughtWorks as a cloud solution architect. I have 16 plus years of experience now. I work with a lot of customers in ThoughtWorks, helping them in their cloud modernization, cloud strategy, and cloud digitization journeys. I'm passionate about distributed systems, IoT, spend a lot of time building IoT stuff, and cloud native applications. So other than this, you're going to find me playing one or the other sports, though it stopped last 3 months. I can change it from here, okay. I'm having a conference month, so I'm fortunate, I would just say that way. I was speaking in Austin in Developer Week Cloud a week back, September 6-8. And then I flew to London. I was speaking there a day before in SRE day. Some kind of similar topic, chaos engineering there as well, but more from an architecture point of view. And finally I landed here, back in India, feels much better. And I'm speaking here, and then I'm going to head back to Pune. So I'm originally from Pune. So that's what it has been.
So how many miles have you traveled since the last?
I don't know. This probably the 10th flight I'm going to take today night.
Yeah.
I don't know what are the sleep times these days.
Yeah.
So somehow I managed to sleep pretty good today, and I woke up at 11 this morning, so I was late. Okay, I think these are standard questions. But yeah, I think if anybody in your organization are building some cloud native applications, are you guys involved in building some cloud native applications, distributed applications in your organization?
In future, it is going to come.
Great. Anybody heard of chaos engineering? Great.
Every project will end
that's a different chaos. This gonna be slightly different chaos. That was a good one. Yeah, I think this is another chaos testing. So this is probably making more interesting now. I mean, being in a QA role, so-called QA role. This is another area which you guys can explore and see if you can contribute and learn and spend time doing this. Normally your performance testing. I know QA have been doing automation, integration, performance, contract test, that's the new one. I think this is another new one which you guys can get interested in. So this is the agenda for today. We'll talk about chaos engineering, why we need it. We'll talk about what it is, some of the principles, these are the theoretical source for setting the platform. I'll talk about one tool, Azure Chaos Studio, because this is cloud native. So I want to use managed service cloud tools for this. So I'll talk about that. I'll have some demos set up. Maybe we'll run through those demos and some best practices and chaos engineering benefits. That's the outline for today. Why chaos engineering? Yeah, this is nice. So cloud outages are unfortunate but unavoidable. I think you have seen this many, and it's gonna happen in future as well because of the distributed systems getting so complex these days. When you build in cloud, you have so much downstream, upstream services. One or the other service gonna go down, and you're gonna face these outages. You have seen this 2021. I think I should update by now. It's 2022 also. We'll get 2022 list as well. One of the famous was WhatsApp. I'm sure you guys remember late last year. 6 hours no WhatsApp. Life was miserable.
People remember that there is something called SMS also.
SMS also, yeah. So it's difficult for us to live without the communication medium these days now. AWS, we may not got affected, but it was during the Black Friday sale in Amazon, and they lost a lot of revenue in one of the region. I think they were down for close to 12 hours. That's bad for them. Azure joined the party as well. They had an area outage for an hour and a half in certain regions where users were not able to log in into Azure environment. So Azure AD. So this is gonna happen. This is gonna happen. You can't avoid it. It's just how you can make your application resilient enough to handle such failures. Is that what we're gonna focus on? Everything fails all the time. I think this is famous quote by Werner Vogels. He's an Amazon CTO, and they accept it, and that's how they build resilience in their application. And they give this 9s, 4 9s, 5 9s. I think I have slide for that as well. I'll talk about that. So what are different kind of failures? Why are we here? Okay, I mean, what are we trying to address? What kind of chaos testing you want to perform? This is one of the failures. Spill milk. It's normal. You can handle this. I mean, this is a kind of treat it as a hardware failure in data center, right? A VM goes down, a storage disk goes down. You can solve this using backup redundancy. So you back up that somewhere, you restore it back. This is still manageable failure, but you need to address this. You need to take care of it. London Bridge falling down. I just went there last week. Oh, a couple of days back. This is, I would say, I won't say catastrophic failure, but this just happened as well. Data center failure. So an entire data center goes down, and if your application is deployed in that data center, in that cloud, the customers will get impacted then and there itself. You can address this kind of failures also in your architecture, but from a chaos testing point of view, how you can test this kind of scenarios also, we'll look at it as well. This is catastrophic failure, hurricane, which was there way back in 2008 in Texas, and Amazon had entire region down. The region comprises of multiple data centers. They had their data centers down, and if your applications are deployed there, who knows? So basically, the idea here is understand these are the failures going to happen to your application. See how you can build those resiliency and how you can test it well in advance if this situation going to happen. That's now I'm going to get into what is chaos engineering now. So you understood why we need it. This is going to happen. You know these fire drills. This is a very good analogy I felt. So basically, okay. So these fire drills, 70 to 80% of time, these folks practice these drills in the control environment. Okay. So they do day in, day out. And when the situation arises, they just go there, apply their mind without thinking a lot. Okay. That's what these do. So they basically practice all these drills in the control environment. Similar case, chaos engineering will do all this testing, chaos testing into a control environment, failure systems, look how it works, and then basically roll it back, whatever failure you have attempted. So we'll look into this. It's a thoughtful, that's important, thoughtful planned experiments designed to reveal the weaknesses of your system. That's the chaos engineering. Basically, those are planned experiments which you run on your system to identify the weakness and see if your system, if your application is recoverable or resilient enough. Okay, sorry. Yeah, everybody got these shots now, COVID-19. I don't know, we should not get any more shots, but you already have to. So what exactly happened with it vaccine? They have injected a virus in our body to fight against the COVID-19 virus. Similarly, what we're going to do is we inject faults in our system to test how our system works and basically make it resilient. We'll remove those faults back, and that's the only difference here. In vaccine, we are not doing. So these are the principles of chaos. This is a pretty great book from Nora Jones. I think if anybody is interested, they should definitely read it. So what are the things we're going to do? We're going to build an hypothesis around a steady state behavior. I'll show you how we do it. We'll introduce real world environments failures, hardware failure, data center, kill the process, all those kinds. I think I have another slide. We'll run these experiments in production environment. We can also do this in pre-prod environment, but this is actually done in production environment so that you can uncover scenarios. So if you don't do this kind of chaos engineering upfront, you're going to get into an outage and you need to do the firefighting there. Okay, so before that itself, you all do all kind of this testing, chaos testing on your environments, and that will just help you when the outage happens. Automate experiments to run continuously. So this is another interesting thing. So there's a CI/CD integration with this as well. The way we have regression test suite, performance test suite, we have all automated, right? Similarly, you can automate these experiments and it can be part of your CI/CD pipelines as well, which can run continuously. Minimize blast radius. This is very important. You want to, you want to introduce faults and you don't want to introduce into an entire system. Introduce fault at one side on one service. Look how your service behaves, and then basically roll it back. Don't introduce faults at all the places, all the services. I think that's an important message. Sorry?
Difficult to trace.
Difficult to trace, and you can't pinpoint scenarios as well. And more important, if you run this in production, okay, this experiment, these are tend to run in production by the way, chaos engineering. If you run in production, if you fail, instead of coming back available, you are making your thing worst. Okay, so we'll talk about it, how we do. So these are the kind of phases: hypothesis, the chaos scenario. We'll look at what we mean by hypothesis. So we basically say this: the system should be available even if one of the data center goes down. That's an hypothesis. Okay. Now you basically perform the chaos testing. You introduce that region failure simulation. You analyze the result. Is your customer still be able to access that particular website or not, even if that region fails? Yes, and if not, you improve your resiliency. At the end, you roll back chaos, whatever you have added it. So these are different fault injection. I think this is going to be interesting for you guys to be aware of, and you can shut down the VM instances. You can crash particular process or a microservice. You can expire certificates. This is very common scenario, right? SSL certificate gets expired. So you can induce that failure and see how your system is behaving. Change access keys, redeploy a VM. Another more important is add delay. This is another interesting thing. So when you call an API, a downstream service, how you can add a delay and how you can basically see how your customer is behaving. So if an API is taking call a weather.com and if it's taking 100 seconds to respond back at that delay, what is your customer looking at? Are you giving some acceptable message, degrading it gracefully? All those scenarios you can test, adding a delay here, and there are many more basically. So a lot of tools doing this. Very famous. This was borrowed. I would say this was born in Chaos Monkey. This chaos engineering concept got born in Netflix. So they were doing actually these things. So they were deployed in AWS massively. They had so much of resources. They had outages, and that's when they introduced this chaos engineering, Chaos Monkey tool, which is pretty much available, open source now. And you can use this Chaos Monkey tool to inject all these failures what I talked about. Litmus is another popular tool. Gremlin and Litmus, I believe. I think Gremlin is enterprise one, and Litmus is again an open source one. But I'm gonna talk about two interesting tools because it's in a cloud native world. Azure Chaos Studio, AWS Fault Injector. AWS also got another tool here, AWS Resiliency Hub. Okay, if time permits, I can show you after the session. That's another interesting tool. But yeah, there are many tools ecosystem in your space, and the idea behind is the same. Inject the failure in the production environment, analyze the result, roll it back.
Just one quick question.
Sure.
So when you are injecting part of it, right?
Part.
Controlled environment.
Controlled environment. I will see in the demo as well.
Okay.
So let me jump into the Chaos Studio Preview. So this is in public preview right now in Azure. So they don't recommend to run this in production environment, which is fine. We can always run that in dev environment and test it out. There are few services supported. VMs, Azure Kubernetes Cluster, Cosmos DB, NSG. It's kind of a chaos engineering as a service. We know infrastructure service, platform service. So this is chaos engineering as a service. So you pay to Azure only when your experiments are running. So you can model your experiment, you can model everything, but you are charged only when your actually running that experiment. So that's the beauty of it. There are two things, agent and agentless service direct. So agent is where on an infrastructure service, so you need to install some agent on the infrastructure VMs, and that will do the induced failure. And there's also an agentless where you use managed service like Cosmos DB. I don't know if you guys have heard of Cosmos DB. It's a database, NoSQL database managed by Azure. So you can inject failure directly on the service. So you don't need to install any agent to do those things for you. So they offer both. Again, support for portal, ARM templates and REST API. So these are mainly from automation point of view. If you want to automate that in your CI/CD pipeline, you can do that as well. So these are the kind of steps. So in a Chaos Studio, I think experiments are the important thing. We'll see how the experiments are set up. Will experiment have the steps, sequential execution of steps. Each step will have branches, and then I think you can introduce the fault and delay. So we'll look actually in demo, so that will make more clear for you guys. But yeah, this is what I wanted to talk about. This is the Chaos Studio. This is your application running in cloud. So if it's running in Azure Virtual Machine, you install this Chaos agent there, and you agent-based pods. But if it's a managed service, Azure managed service, direct pods can set it up here. So the steps for Chaos testing, this is interesting. Define the steady state, introduce Chaos, verify steady state, and roll back Chaos. I think those are the 4 major steps for any Chaos testing you do. I think I jumped for a demo. Fantastic. So this is a voting reference application. Pretty simple standard application. It's a client application. We have a load balancer. Deployed in Kubernetes, blog. So this is one of the sample application I'm using for my demo. And give me a minute, I will sit down. There are 2 demos which I planned. Check. Okay. So I have 2 demos. The first demo is, what we'll do now here is NSG, Network Security Group. Okay, so we will block one of the firewall. So these are the resources which are deployed there. So you have a virtual machine, you have just deployed an Hello World app there. Nginx, I believe Nginx has been deployed in that VM. So let me open up that URL. So it's running. So let me copy this and open in an incognito window. Okay, welcome Nginx. So Nginx is deployed on that VM. And now I want to show you what all resources we have other than that. I think it's pretty much VM disk, deployed in our VNet. That's it. Nothing fancy. I would just kept it very simple. Okay, so now this is an Chaos. Let me show you this tool before I jump into an experiment. Show you an experiment. Okay, so you're gonna see this icon Chaos Studio. This is the Azure Chaos Studio, and these are the targets you need to configure first. What all targets you want to run this experiments on. So I've defined all the targets. So if you are running in your production environment, all the production requirements you need to add as a target here. So you need to require IAM permissions to access these experiments. So add these targets.
All in the sense from the database.
Yes. Entire thing. Whatever targets you have, you have to define it here. Then you can use this. So I'll just open one of the experiments. So exactly this one. This is Chaos NSG demo. So So what we are doing here is, let me open the experiment. This can all be automated, as I said. This you're going to see it manually. So what I'm doing is I'm changing an energy inbound rule. To show you what I mean by energy inbound rule, I'll add a deny web rule. So basically what I'm doing here is, so I'm denying, I'm adding an failure energy firewall, I'm blocking that firewall 8443 for a given minute, and the action is denied. So now you are able to open the website. So the moment I induce this failure for a minute, it will basically add a firewall rule. So we'll see that actually as well. So let me go back to resource group. This is the virtual machine. I'll show you the energy networking here. Pretty straightforward here. Okay, what is this? Oh, sorry. I did some change before I came here. I did not change it to allow. I'm just updating it.
The automation depends on the cloud platform.
Yes. I mean ARM template. So here it's an ARM template, bicep template. In Azure, in AWS you'll have cloud formation. But I think you can still use Terraform as well. I've not tried my hands there, but you can also use Terraform to kind of automate these things. But right now they expose a REST API, right? So you can basically call those REST APIs to run your experiment at a scheduled interval from your pipelines. Okay, so these are the networking rules right now. So if you see, everything is allowed. Mainly this is the SSH port, mainly this is the one 8443. So default allow web. This is the 200 priority, and any you call from any mobile or anywhere, this is allowed. So that's the reason. If you see, you are able to hit this point and get it. What I'm going to do is I'm going to inject a failure. So I'll just cancel this and I'll start this experiment. So this is when Azure is going to start hosting when you run your experiments. So it's going to identify some resources for you from their data center and run this actual experiment there.
Basically, you are paying this as a service.
Yes, chaos engineering as a service.
And you are consuming this service and paying.
Yes, only when you are using it. So you can model your experiment and you can do it.
Basically, like big billion sale and all, that time I'll be consuming more, so I'll be using more. And when it is idle, I'll be paying less.
Yes, yes. That kind of model, pay for use. Similar serverless model. When there's a high traffic, you pay for that. Similarly, this is kind of pay for use experiment. So when you are running your experiments, only you pay for it.
And also scalable.
It's scalable.
One quick question.
Sure, sure.
So, as a hacker or someone who wants to create disturbance in the existing system, I can use chaos engineering to disturb the existing
But
system.
they need to have access, right? They'll directly do it in that case. They won't need. Chaos engineering needs to be done in a controlled environment from a trained user. Hacker will directly jump and make these firewall changes. Okay, so what I did is, if you see, I run that experiment, it added this deny rule automatically for a minute. So it added this deny rule on top of the allow rule. So this is an 101 priority. It executes in an order. So it's an 101 priority. So Chaos Studio deny web. So it's introducing that fault. And at this point of time, if you try to call this, this is not working. See, this is hanging on the top. If you see, this is working. So this is not responding for a minute. Now this is your steady state. Now you need to identify how your customer will behave if there's challenge in a firewall rule. Do you have a redundant system running at somewhere? Do you have a traffic manager? Your customer is blocked now. So now you need to build a resilience in your application. Now you need to think backward. You need to introduce a load balancer. You need to have this running in another VM. So if this firewall goes down, if there's some problem in this hardware, your customer is not impacted. So
basically, are we testing infrastructure, right?
Infrastructure.
That is the main.
Infrastructure testing. Yes, absolutely.
Okay.
So now after a minute.
So what is the tool like? It is inbuilt like Azure. They are providing this.
Azure is providing.
One more tool I forgot. Unable to recall.
Kiosk Monkey is Litmus, Gremlin. There are a lot of tools I think I have shown in the slide. You can use any of them. Fundamentals remains the same.
Okay.
But I just wanted to give you an idea. This is an area where you can, as a QA community, can get into SRE. These are generally done by an SRE, site reliability engineering. They are specialized for this. But I think if you master some of these tools, you yourself can get into this.
What's the best practice like? When do we need to run on daily basis or like?
Yeah, I'll come to that. That's a good question.
Okay.
I think that depends on the maturity of your team. But the more often you do, the better you are in. Okay, so this is, if you see after a minute, let me go to an experiment. So it ran successfully 2:17 p.m. Okay, so the experiment ran, and now if you see back in VM, so that he had rolled back that fault what was introduced. Okay, the fault was rolled back. And now you go back here, it's pretty fine. See, you can just access. So basically, this is one experiment, one demo. Let's go back to this slide there. So this is one demo, network disruption, what we saw. Let's look at, this is an interesting failure, high availability disaster recovery. Okay, this, I'm sure you guys are aware of it.
Is this related disaster recovery and chaos engineering both are same?
Disaster recovery is basically when the disaster happens, your application should be able to recover out of it. Chaos engineering is a proactive step to test disaster recovery, if it's happening or not. Okay, so disaster recovery will happen. If it happens, if it not work, have you tested it? No. Chaos engineering is a medium to test it upfront, proactively. Think of Selenium, right? You use Selenium to test the functionality of your application.
Actually, even in our organization, we turn off some loads and we generate some loads. So we
Yes.
just check whether it is going to redirect it to a different load balancer or not.
Yes, yes, yes. So that can be done through chaos engineering tools. Now,
It's similar thing.
similar kind of thing. Exactly. So this is an HADR test where this is the application what is deployed now. So make it very simple. There's two regions. It's deployed in two regions. In region deployed in primary region and a secondary region. So in cloud you have active kind of setup where you have deployed one application in East US region and the same application is deployed in West US region. Now if your East region goes down because of, you remember hurricane, I showed you that image, right? Catastrophic failure. Something happens, your East is down. Your customers are not impacted because your secondary region is up and running and it's able to serve your customers. More importantly, your data is continuously replicated. So you have this data tier, SQL Server. Data is continuously replicated. So if any stateless workload had done some action on that primary region, it can come back on the secondary region pretty seamlessly. So let's demo this. This should be an interesting demo. Bear with me, I have not done this lately. But okay. Oh, sorry, I'm looking at this. So we'll go to resource group. We'll look at the traffic manager demo. So there's a traffic manager in front of it, which is kind of a load balancer, which basically takes the IP request and cascade it down. So now what we are doing here is there are a lot of resources here. Most important resources are two VMs. Okay. So virtual machines. You can see this is the first virtual machine, and this is the another virtual machine. You guys can see, right? Good. So this is deployed in East US. If you see, the same application workload is deployed in both VMs. This is in East US, this is in West US. Now what we're going to be doing now is, let me show you the existing application. traffic manager demo. And you can try, I believe, on your mobile phone also, but I think the URL is a bit complicated here. Else I would have given it to your mobile phone also. So this will, this is right now, if you see server 1, that's basically running from the east US. Okay, so the application is responding from east US region. If I do, maybe I should do it caches, right? Once you node affinity or server affinity, my IP address has been recorded, so it will always respond me from server 1. That is good. But if somebody tries to call the same URL from some another machine, they may get response from server 2. Same application is deployed at both locations. Okay, so now what we're going to be doing is we're going to induce failure. So see, this is the traffic manager. It has an endpoint. It's connected to backend VMs, both VMs. And there's a health endpoint. The endpoint is healthy. So round robin fashion, it routes the traffic here and there. What we're going to do is we're going to look at an experiment first quickly before we run that. What I'm trying to do here is okay. Oh, this is fine. Somebody changed it. So I'm stopping at East US VM for 5 minutes. Let me see if I can change this to 1 minute. 5 minutes will be difficult for us to come back and see. Let me make it 1 minute. Is it saved? So what I'm trying to do is, I'm stopping and I'm crashing that VM itself. I'm inducing a failure VM. You can induce any kind of failure, okay? So this is add action. So you look at this add action, add a fault. You can add a delay also.
Or you can simply
Shut down, fault, NSG rule change. So see, these are the faults provided by Azure. And each of the tool will provide you a lot of. So CPU pressure, you can increase the CPU pressure on a particular node. You can DNS failure, you can inject a DNS failure. They can keep on adding things here. That's the beauty of using the cloud services, right? Network latency, you can induce a network latency. You can start, stop, manage services. These are all the failures you can try. VM shutdown. I'm just using the VM shutdown right now, but there are many actions, fault actions, which you can run. Okay, so let's go back.
VM shutdown for 1 minute.
1 minute. Yeah, but I don't know if it's going to change or if it's 5 minutes, that's fine. You can see it later also. Let me save it.
Do you have any live logs for this?
The application logs will be there. There's also auditing happening on the who ran the experiment, how much time the
For
experiment.
this one, can we see this live logs?
Yeah. Okay. I think it's saved. So these are the logs, history, when you ran the experiment.
See it.
Yeah. So when you ran the experiment, you're going to see the activity logs here as well. So let me start the experiment now. So we're getting response from server 1. I believe we'll get response from server 2 now. Because we have failed one particular region there. So this is what you can do this in pre-prod environment. To answer your question, generally this chaos engineering is being told to do in prod environment, but I think you can run it earlier in your queue environment, in your staging environment. Before you do it, you should definitely do in prod environment, because when outage happens, I was part of many outages, and you have very low IQ at that point of time. You can't think, because so many people look at you. You have so much customer pressure. You have your manager looking at you. You have your colleagues, and it can happen abruptly at any time. You can't think. Okay, I think I missed one slide to add it here. You always know that 949s, 39s, 99.9% availability, 99.9. Let me see if while this is happening. Okay, so this is running. Now let's quickly see. This is the traffic manager URL, right? We were getting it from server 1. So now server 1 is not responding. If you see, now it's 1 minute. So let me quickly show you. Should respond from server 2. It's not doing that. It's introduced a chaos, another chaos. Let me look at, okay, did it respond? No, not yet responding. Fine. So let's quickly look at the VM. So you look at the first virtual machine, should be stopped now. It is stopped. And the second virtual machine should be up. Should have responded from here, West US, but I don't know, maybe some problem in my demo. Ran it up for some lot of
What
time.
I was asking is the CLI, not the messages, okay? So that like how you have IP running
Yeah.
or something like that.
So let me try that also. Yeah, this server 2 is responding, but the traffic manager should also look at it. Traffic manager will look quickly because this 1 minute will get over any time. And by the time, see, this is degraded. Endpoint 1. Okay, endpoint 1 is online, and this guy should just respond to this West US region and should respond back. And oh, thank you, server 2. So it responded from server 2 because we failed server 1 region in East US. The traffic is diverted to West US region. So this is the server 2. Sorry, I think
there
I'll.
was some latency.
Yeah, there was some latency happening here and there. And after some time, I think after the experiment successfully run, it rolls back that VM up. This will automatically be online. We can see in some time. So until then,
Assume you have like two servers. One server is shut down. We have only one server now. Like many requests are there, you cannot respond to the CPU memory issue.
Yes.
So how this
so you test that also. You can test that also. You can basically have this experiment chaining steps. First you fail this VM, then you introduce load testing on that the other VM.
Yes.
You make a CPU spike and see how your application is behaving. You can test all those scenarios upfront before that happens in outages. And you can give your feedback back to developers. Your application is not working when it comes on load, when one region is down, and basically they can do the optimization at their own side. There are a lot of application resiliency patterns which I am not covering in this session, but they can implement back in their application as well. So this is how you can give feedback back to your stuff. So if you look at an experiment, let's quickly go it. 2 minutes. I think I'm almost done. This experiment, I think it didn't change to 1 minute. It's just running for 5 minutes. But if I wanted to show you one thing, this was the first step we added, right? The next step we could add on specific VM, step 1, you can add another step here. Now I cannot do it because it's running now. Introduce load on the other VM, West US VM, and see how your application is doing. That's how you can change your experiments and do it. Okay, so this is going to take 5 minutes. Let's go back to the slides and finish the slides and see if we can come back. So many windows open here. Okay. Key takeaways. Fantastic. Last slide. Yeah, we have good enough time. Shift left. You have heard this terminology a lot. I think this chaos testing can be shift left. To answer your question.
What does the mean of shift left?
Shift left, basically you can do it much early. Generally chaos engineering is been told to do only in production environment, but with these automated tools, part of your pipeline, or even you can start with manual, look at your QA environment, pre-prod environment, identify the failure points and run it. So run your experiment early, don't wait for to do it in production. Shift right is obvious. Chaos engineering is meant to run in production to basically learn control environment. Again, you can't do it every time in production, but you basically identify the game days kind of scenarios. On one fine day when the traffic user will not be using it, run your experiment, see how the system behaves. Train your employees. Everybody should be trained to look at logs when the outages happen. Okay, that's the shift right. Define error budget. So error budget is a concept, I think I missed one slide, but when they call 3 nines or 4 nines, you know how much time you can have your system down. When it's 99.99%, you can be not available only for 52 minutes in a year. Okay, only 52 minutes in a year you will not be able to available to your system. If you exceed that, you will be penalized and you need to pay for it. So when an organization gives you 99.99%, means that they can allow only 52 minutes of downtime. In RCA, I know 1 hour it takes to identify RCA only during RTA, what happened. Okay. So this has to be baked in. All this testing has to be baked in. So when I say in the fire drill, right, when they do 80% of time in this control environment, when they go, they just apply their skills. They don't think. They start thinking during the fire drill, oh, how to do this, how to do this. It will just happen. Similarly, when the outages happen, your developers, you yourself logs, when you analyze the situation on the cloud, you don't need to overthink, you just apply whatever you have learned from your experiments running. That's the intent. So you need to establish an error budget. So out of 52 minutes, 20 minutes you should, in production you will be down when you run this chaos experiment. So you should give some investment for chaos engineering as well. But I would say you should start doing in pre-prod environment. That will give you a lot of confidence.
I think very difficult to advocate on production, as you said.
Yeah.
52 minutes वैसे 20 तुम खाए होगे तो 30 minute is not.
Absolutely. You are absolutely right. But there's nobody gonna stop you in doing in pre-prod and queue environment. So you should do it.
That's right.
Basically, that's what my intention is. Automate your experiment using ISC. So if for some reason if something goes down, right, you're introducing a chaos, the way I was. But the system cannot recover back. Okay, you're on shotgun. So you need to make sure you have infrastructure code to spin up that environment pretty fast on the another side. I mean, think about failure of failure. That's what it is.
What IWC?
Infrastructure as a code.
Okay.
So automated deployment, provisioning of resources is all by infrastructure as a code. Familiarize team with monitoring tools, practice log analytics. This is very important. Most of us, when the outage happens, they don't know where to look at it. From where to start. Why it happened. I think this kind of chaos engineering experience, when you run it, your team are trained to look at those basically log stuff. This is another good thing. I'm still in debate there. Form a chaos center. We have security team in every organization, right? Cyber security team, CSO team will do the security assessment for your all the projects in your organization. Similarly, I think if we have some chaos team who will run this chaos experiment for all of your projects. That's one way of looking at it. Google does that way. Amazon does the other way. So Amazon, whoever builds their microservices, that team will own the resiliency testing for it. So it's whatever works for your team. I'll start with this and then come back to federated kind of model. Yeah, so game days, that's another thing what I talked about. Yeah, so this is the last slide, chaos engineering benefit. I mean, it increased the availability for your application and it reduced the MTTR, mean time to recover. So what does this mean is when an outage happens, you can recover it fast out of that. Those are the clear advantages out of it. I think that's pretty much what it. We can quickly look at the demo if things have sorted. If not, I think we can look at later as well. So now let's look at the traffic manager. Okay, both are online now. So that VM got on again and traffic manager was able to detect it and now traffic can go back anyway.
Now if you check, it is on server 1.
It can be server 1 or server 2. Both are up. Okay, so that's pretty much. I'll be available on LinkedIn for any questions. If you have, you can feel free to connect to me on LinkedIn.
Yesterday sent.
Sorry?
Yesterday we sent.
Okay, thank you. I'll accept it in case if I'm not.
Sent before the session.
Okay. So yeah, I'll be there and feel free to connect to me and that would be great. Thank you. Any questions for me? I think we have asked a lot of questions, but.
Small input.
Okay. That's okay.
Ah.
Proceed.
Oh, thank you very much.